All right, so hello everyone. Welcome to the March 2025 Link Tech Talk. My name is Colin Ryan Chandler, and our co-host is Mi Dai. We are both Link Frameworks product scientists. I'm at the DRAC Institute, University of Washington, and Mi is at University of Pittsburgh. These Link Tech Talks include presentations and demonstrations that showcase work done by the broader Rubin software and archives community with the goal of enabling LSST science. Unlike traditional talks you might hear at a conference, Tech Talks highlight the technical aspects of the work being done. We hope these talks provide a useful forum for a range of groups and authors to present, learn about, and discuss efforts of interest in the analyses of LSST data. The Tech Talks are delivered virtually every second Thursday of the month at 10 a.m. Pacific time. And today we are joined by George Beckett, University of Edinburgh, who's going to talk to us about progress towards a UK-based independent data access center. George, who has a background in computational mathematics, has vast management experience across many projects, way too many to list here. But we're very excited to have him here to talk to us about the UK IDAC. For the talk, please ask questions in Zoom or on the Link Tech Talks channel on Slack. On Zoom, you can type questions into chat or raise your hand. As a friendly reminder, these talks are being recorded and they will be posted on the YouTube channel in the future. We do ask that folks hold their questions to the end of the talk, if at all possible. And so without further ado, George, please take it away.
Okay, thank you very much. Hopefully you can see my slides now.
Looks great.
So hello everyone. As Colin has said, my name is George Beckett. I'm based in the University of Edinburgh, and I'm going to talk to you about progress we have made with the UK Independent Data Access Centre, which is part of our offering through the in-kind program. It occurred to me while we were waiting to start this talk, I've put a picture on my first slide of Rubin, but then that's usually quite impactful, but here it's probably quite dull. I think I should have put something UK more focused, so it's a bit late now, but I will remember that for next time perhaps. So I will try and make this technical, but I am going to give you a little bit of background. Some people have heard me talk about the UK IDAC before. If so, I apologize. Hopefully this is a useful refresher, but I think it is worthwhile spending 5 minutes just giving you some of the context. So in the UK, we have been quite fortunate and maybe quite organized in that we've created what's called the LSST UK Consortium. This formed around about 2011, 2012, and every single astronomy department in the UK has agreed to work together to maximize the benefit of the LSST, of engagement with Rubin for the UK astronomy community. And the LSST UK Consortium is responsible for securing and then managing all of the funding that we apply for here in the UK through our sponsor, which is UK Research and Innovation, an organization called STFC, which some of you may know. And they have also been responsible for engaging with Rubin and have delegated responsibility for administering our Rubin data rights. Some of the key names in the consortium that you may know. Our project leader is somebody called Bob Mann. Bob Mann's based here in Edinburgh alongside me. He has been the lead of the consortium since the very beginning, or pretty well the very beginning. We have a project scientist that many of you know, especially if you're involved in commissioning, because they're also the commissioning coordinator. That's Graham Smith from University of Birmingham. Reasonably recently, we have appointed a communications officer, Eleanor O'Kane. This, I guess, reflects the imminent arrival of Rubin operations and a great increase in publicity and interest in the science of the observatory. And myself, along with somebody called Terry Sloan, are part of the project management team for the UK contribution. And we also have a board chair, which is Mike Watson from Leicester. So I have mentioned the in-kind contribution. Originally, the way that international partners engaged with LSST or with Rubin was through a subscription model. But around about 2019, that changed and we moved to this in-kind contribution model, which hopefully many of you are familiar with. The UK has developed a pretty substantial package of in-kind contributions, and we're going through the final stages of agreeing them now. But from a computing perspective, probably the four most interesting elements are a contribution to data release processing, which is the preparation of telescope observations into science-ready data products. And we've committed to doing a quarter of the processing here in the UK, which is alongside our colleagues in the US, based at SLAC, and colleagues in France at CCI and 2P3. The talk about today is mostly about the Independent Data Access Center. We've committed to providing a platform on which astronomers can exploit and analyze LSST, and we've sized that, or we will size that, to serve 20% of the estimated Rubin community, which, based on various tech notes and documentation, is around about 1,500 data rights holders. We also in the UK operate a community alert broker, and that's been approved as one of the official Rubin brokers. Some of you may be aware of that already. It's called Lasair. I'll talk a little bit about that later, although I'm less involved in that, so my understanding of my delivery may be a bit more sketchy on that. And looking at UK science priorities, we are proposing to generate a number of what the observatory calls user-generated products. So these take the data release and they reprocess it, or they augment it, or they otherwise manipulate it to produce new science products that serve particular communities and particular science questions. As I say, there are various other contributions we make, but they're less computational and possibly, hopefully, less interesting for this talk. So LSST UK, as I said, the consortium has come together to organize all of the funding, and it's created a what is now a 5-phase program called the LSST UK Science Centre. Our first funding went back in early 2015, which was before I was involved with this project. I joined in 2016. But typically each phase is around about 4 or 5 years long, which coincides with the extent of funding that our research councils can support. And nominally, we've gone through a sort of development phase, which was establishing a relationship with the observatory, beginning to understand the capacities and what was involved. What was called the commissioning phase, this I think was on the original LSST timescale, and I appreciate things have slipped, and you could argue we're still in the commissioning phase now. Early operations, which is the phase we're in now, and then 2 phases of standard operations through to about 2036, which is roughly a year after the end of the survey. I suspect that will extend again slightly, given the timing of the operation at the moment. And we have now an agreement with SDFC to fund us in principle through until the end of 2036, with a total forecast budget of around about £73 million, of which 26.4 million is set aside for capital, for infrastructure to support our in-kind computational contributions, the ones I showed you on the slides earlier. The way the infrastructure will be provided in the UK is slightly complicated. It's through a separate program called IRIS, which I'll describe briefly here. IRIS is a cooperative program which brings together all of the major experiments and facilities in the UK from the particle physics, astronomy, and nuclear physics area. So one of the biggest communities in IRIS is LHC, or our contributions to LHC. But we also have significant contributions from the Dune experiment, from the Square Kilometre Array, from the Euclid telescope, and Diamond Light Source, which is a synchrotron here in the UK, which you may not be familiar with. To be fair, it's more of a UK-based resource. And together we came together and said we all have significant computing requirements. Potentially there can be an economy of scale here, and by working together we can secure the infrastructure we need without having to do everything independently. This is more palatable for a research council, and it's also potentially more palatable for the individual experiments, because we can share expertise, we can share knowledge, and we can collaborate on the delivery of these kind of infrastructure services. Iris offers a range of infrastructure. Some of the sort of high-level elements are cloud computing, mostly aimed at running sort of services. And in the UK, that's all based on a variant of OpenStack called Scientific OpenStack, which, to be honest, looks very similar to OpenStack, but it's oriented towards supporting research computing and scientific computing rather than finance and business services, which is maybe where OpenStack's main markets are. High performance computing, we're not as well set up as the US in terms of our high performance computing capacity, but we do have a number of significant facilities here in the UK, and we can access these through the IRIS program. Grid computing, which is very much the LHC computing model, distributed computing, and the UK is quite a big part of that. And also we have a relationship with the UK NREN, which is called JANET, which is the high speed network that connects all of the institutions within the UK. Iris also provides various sort of supporting digital assets and digital services, things like federated authentication, accounting, security, and the like, which again, this is the economy of scale. It means that individual experiments don't have to specifically worry about those things. LSST UK has been a partner in IRIS since the very beginning. In fact, I was a co-I on the very first proposal back in 2017. And our plan is that IRIS will be our vehicle for delivering the infrastructure throughout the lifetime of the survey. So if I now get on to the UK IDAC, just a reminder, a data access center is the way that astronomers will engage with LSST and where they will access the data and do their analysis and their science. Given the scale of LSST, this is very much a case of bringing the compute to the data, and this is a model that astronomers will hopefully very quickly get used to and begin to see the advantages of. The project has specified two project data access center. One is in the US. It's a hybrid model. It's based in Google Cloud, but some of the services are offered directly by Slack. And there is a second data access center in Chile, which I think primarily serves the Chilean community, but they're the two project DACs that run. And then in addition to that, there are currently 13 independent data access centers from groups around the world who have made in-kind contributions to provide extra resource to allow astronomers to do their research. And they are split across the Americas, across Europe, and in the Asia Pacific region too. Different IDACs, provide different functionalities, different capabilities. Some of them are very specifically tailored to particular science cases or maybe tightly integrated with particular science collaborations. Some of them are more general. The plan to get the data to the IDACs is maturing quite quickly now and looks to be based around two technologies that you may be aware of called Rusio and the File Transfer Service FTS. So Rusio is a distributed data management system. It's a policy-based approach to making sure that data resides where it needs to in order to fulfill some policies you specify. And the means with which it does that is typically the file transfer service, which automates the movements of potentially very large amounts of data very efficiently in the background. And FDS and Rusio is the way that the Rubin Observatory plan to distribute data release products and potentially ancillary products to data access centers. If I look specifically at the UK IDAC plans, so we are proposing to run what's called a full independent data access center. I think currently we're the only full independent data access center, and that means we will host complete data release product suites. We are proposing to host the two most recent data releases, which is in line with what the US DAC is planning to do. We're also proposing to run the Rubin Science Platform software stack, which if you have used data.lsst.cloud, that may or may not be the URL, but it's some combination of those words, you'll be familiar with. And as I said earlier, our plan is to provide enough capacity that 20% of the community can use our IDAC. Being a full IDAC, being a fairly generic IDAC, it will look very much like the US IDAC, or at least the US DAC, or at least that is our plan. However, we are planning to host the in-kind data sets that we are creating here in the UK that I mentioned on earlier slides, and to augment the LSST DR offerings with various ancillary data sets that certainly are of interest to UK scientists, probably interesting to the international community too. Excuse me, I've got a bit of a frog. Give me a second. Sorry, this is going to bode well, isn't it? Right. In terms of data holdings, so a full data release is quite a substantial amount of data. And it means that each year we are looking to ingest and then serve around about 8 petabytes of deep COAD images. The deep COAD product doesn't grow in size year on year because it's actually the stacking of all the images, and so it's a fairly consistent size throughout the life of the survey. We're also going to host all of the produced catalogs. They do grow in size over the course of the survey as more observations are taken and more detailed measurements can be calculated on the various things that are detected. And also the single visit images, the single epoch images, again, they grow over the lifetime of the survey, such that by the end of the survey, we're expecting to have around about 200 petabytes of data, which is accessible through the IDAC in various means. It's likely some of that data will be more accessible than others, and it also depends on exactly what modem access you're interested in. But that's the plan, to have all of that data accessible to astronomers. In terms of user-generated products that we're interested in here in the UK, I talk a little bit more about these later. Currently, we have 3 or potentially 4 such products. The first is a group who are planning to fuse the LSST data release with overlapping near-infrared surveys, primarily in the first instance the VISTA survey, and this is to sort of naively give you extra bands of observation and to sort of enhance the information that's stored in the images based on that. We're expecting that to produce around about 2 petabytes of images and catalogs per year. There's also a group here in the UK that is developing a new cross-match algorithm that's specifically designed to be very accurate in crowded fields, which is a problem within LSST because of its sensitivity, and to actually run and create cross-match catalogs for various topical surveys, around about 5 or 6 ancillary surveys that are complementary to LSST. And we're expecting around about 500 terabytes of catalogs in addition to the data release from those. We're also running a solar system transients classifier, which is part of our alert broker service. It's called Adler. I don't have a lot of information about that here, but I can certainly put people in touch with the team who are working on that if that's useful. And as I've said, we are planning to support a more general interest in being able to jointly analyze LSST with other contemporary surveys or other significant surveys. And we are co-located with the UK Community Broker Lasair. This is a sort of picture we've had for some time, which kind of explains how we see the UK IDAC being laid out in a sort of technology way. So there's a range of colors on here, but can you actually see my mouse pointer? Is that sharing okay, or is that hidden from you?
We can see it moving.
Okay, cool. So over on the left here, you've got the observatory, and the observatory will deliver products via 2 mechanisms into the UK IDAC. First of all, each night it will deliver a live nightly alert stream, which is fed into the Lasair Community Broker here, and then that goes through various processes before it's made available to the users of Lasair, the alert broker community, who are interested in transient astronomy primarily. And then roughly once per year, a fairly large transfer of data will happen as we receive the data release from the observatory, from the data facilities that are processing that, and that will both be ingested directly into our science platform, which will run in blue here the various components that the Square team, the data management team in LSST are producing. It will also feed into various user-generated product generation, and that's the green objects here. Things like the near IR fusion and the cross-match data, which we will process locally here in the UK, and then they will also be deposited in our data access center alongside the LSST data releases and in a compatible way that makes them easy to accessible. And finally here, I'm going to say this is purple, but this is where I tell you I'm colorblind. But the darker color over here, represents ancillary surveys that aren't directly conjoined with LSST, but are potentially relevant. Here we may host them locally, but more likely we would provide remote access through things like the TAP interface, the catalogs, and so on, and you would access them at source from the science platform. For some time now, we have operated what's called a UK IDAC roadmap, and the idea here is to explain to the early user community what our IDAC will provide and when. Currently, we're at UK DAC 4. which was delivered in March last year. We roughly deliver these every year, but unfortunately the next one is slightly delayed, and that's because it ties in with Data Preview 1, which is currently slated to be available around about June, July this year, I believe. But you can see there's a lot of commonality on here. I guess because we've missed off UK DAC 1 and UK DAC 2, some of these things grew quite quickly to where they would be stable. So as I've said, we're planning to offer all of our infrastructure via Iris, and we're planning to run the full RSP. In terms of data holdings, we've had various data sets accessible for some time. There is a UK archive called the Wide Field Astronomy Unit, which is based here in Edinburgh, and they host a number of astronomy catalogues from various surveys. Via their TAP service, we have made those available through the RSP. You could argue that's not very complicated. All we had to do was type the URL and we were there. But we have also ingested DP01, which was the original data preview from the desk science collaboration, and early versions of fused datasets involving Vista and HSC, and cross-match datasets based on Gaia and Catwise. Currently, we have DP02 in our DAC. We do not have a full DP02. It's quite large. We have all the catalogs, but only a subset of the images. This is mostly for internal use. DP02 is hosted by the US, by the project, the US DAC, sorry, and so there's little reason for us to do that. We also have DP03, and we have a subset of ZTF data release 20, which is primarily being used to explore integration between LASA and the DAC services. We've actually dropped DP1 to save space. DP2 effectively is a straight replacement for that. Currently, our authentication is based on an old model. If you've been engaged with the project DAC for a while, you'll remember you used to log in using your GitHub credentials. Here in the UK, you still do that. We are planning to move to a Rubin compliant model by the time we publish DP1, but that is looking tight now, I think. One of the reasons we're struggling to deliver on that timescale is that we're trying to be slightly more flexible than the very very vanilla Rubin authentication model, to allow us to provide access to other potential proprietary data sets and to manage that slight complication of having a user who has data rights in one set but not another, or potentially data rights in an overlap of two, and also to provide public access, which the nightly alerts are available through. Excuse me. In terms of documentation, we're mostly relying on the project. We are providing documentation for some of the user-generated products we've added to that, but pretty well everything is what you would get from the US DAC. And in terms of our what we call our help desk, in terms of our science support, we are using the community forum. And the idea is that if you're a UK IDAC user, you will engage with us in the same way that you engage with the project DAC using the community forum. There is a UK IDAC topic on the forum. It's currently very quiet. We don't have a lot of users yet, as I'll show you in a little while. In terms of some implementation details, and I don't go into a lot of detail here, but if people are interested and there is time, I'm happy to talk more later on in the session. So we're running the Rubin Science Platform. We're hosting early data sets. We also are running Qserv, which is the project's scaled relational database. We have a 10-node Qserv, which is quite small compared to the project. I think the one that you access via the project DAC is currently around about 50 nodes. So ours is also based on spinning disk, so it's slower in that way too. However, for a range of queries, it performs pretty well. There are queries you can run against it that will run like a dog, if that's a reasonable thing to say. But it actually doesn't do too badly considering the scale and the underlying technology. We're tracking, or we're trying to track, observatory data releases. We're a little bit behind. Currently, I think we're on the December 24 version of the Science Platform. So if you're aware of the new tutorials menu that appears on Nublado as of a couple of weeks ago, that's not available on ours and probably won't be available on ours for a couple of weeks yet. And our Qserv instance is the November 24 Qserv instance. But we are trying, as we get closer to the start of operations, to bring our software stack more into line with the project software stack. All of our services are deployed on top of Scientific OpenStack, as I said earlier, although that's mostly hidden from the services, as pretty well everything is containerized in Kubernetes, which provides a layer of insulation between virtualization and the front-facing services. The one exception to that is Qserv, which we run a little bit like an apparatus. There is a debate going on at the moment about exactly how we will deploy our Qserv instance. Currently, it's deployed on a static virtualized hardware. We are not 100% convinced that is good enough. We may have to switch to a sort of bare metal based approach, which is actually supported in OpenStack, ironically, and by a system called Ironic. So that's something we're going to work on over the coming weeks. I think I've covered all of this already. Effectively, these are our current data hosting holdings. And in terms of next steps, there are two kind of orthogonal things that we're dealing with. First of all, we want to ingest DP1 and we want to make that available to the community as early as possible. We see that as an excellent experiment for us because it is the first genuinely observed data that we'll have from the telescope. But secondly, it is a way of growing our user base. One of the challenges we've faced is that there isn't a lot of reason to use the UK IDAC at the moment. We don't have a huge amount of scientifically valuable data, and most people are too busy to play with technology without a genuine use case behind it. So DP1 should be an opportunity to really engage with users and get them to use our systems in anger. We're also experimenting with remote image data access. Coincidentally, the project is doing that. You may have seen that they have moved to a hybrid system as of around about a week ago, where some of their data sets are hosted in Slack and some of their data sets are hosted in the cloud. We are doing something similar, but for different reasons. So our IDAC is based in Edinburgh, and all of our core data sets will be hosted in Edinburgh, but we do not have the space and capacity to hold 200 petabytes of data there. And so some of what we are calling the cooler data sets, by which I mean the ones that are less frequently used or maybe used in very specific modes such as batch processing, we're planning to host at Rutherford Appleton, which is a national lab here in the UK. They have far more capacity to host very large data sets and to make them available via the internet and the S3 interface. And that's something we're experimenting with just now. In terms of Qserv, as I said, we currently have a 10 node instance that's running on spinning disks. We actually have new hardware arriving, I believe, this week, which will allow us to grow or replace that 10 node instance with a new 15 node instance. And that will be based on local NVMe storage. And the actual chosen architecture has been based on some benchmarking experiments that we've been running over recent months and quite detailed discussions with the Rubin DM team about how best to secure the sort of performance and the capacity that we need. It turns out our workers will look very like Rubin workers. We will just have a slightly smaller set. The system is sized at 1 petabyte, which is enough for the early science requirements, and it's also scalable so that we can. The idea is that this will be the base for our production Qserv, and we will grow this over time as we need to add more capacity for more data releases. The plan is that will be deployed in early April. I'm conscious it's early March and the hardware hasn't arrived yet, so depending on the definition of deploy, it's probably going to be more like May before this happens. But we are looking to have this online and commissioned by June, so it's ready for DP1. We've done a lot with Qserv over the past year ago. One of my sort of slightly jokey requests of the team is to break Qserv as much as they can, because what we don't want is to rely on something that's so fragile we're scared to touch it. If we're going to break it, we'd like to do it now and learn how to fix it. And I think we've done a fairly good job of that. We now have an automated deployment mode for Qserv, which allows us to spin new instances of Qserv up on virtualized hardware in just a few minutes. And so alongside our 10 node Qserv, we actually quite frequently have test instances that we spin up and destroy at will. We are now able to do in-place software upgrades. I don't know if many people here have been sort of using Qserv in anger or administrating Qserv in anger. Early versions, it was very difficult to upgrade. Typically, you had to set up a new instance and then migrate all your data across, which was very expensive. I'm pleased to say that in-place software upgrades are now possible. And we have worked on expanding and shrinking the worker pool, expanding it so that we can buy hardware as we need and size it to the particular data sets that we're looking to host. shrink because occasionally workers fail, and we want to know what happens when when that happens and how resilient the systems are to this. The project is planning to run I think, a 2 replica or a 3 replica Qserv, which means every record is held on at least 2 or 3 workers. We don't have the budget for that. We are running single replica data sets, which means if a Qserv node goes off, those rows disappear from our tables. We are backing up to spinning disk each node, so we are still experimenting with this, but the idea is we would spin up a new Qserv worker and we would re-ingest the data for that node from the backup, and then we'd restart the service. And that's hopefully how we will manage a resilient Qserv, but without the cost of being able to support 2 or 3 copies of the data. Qserv has a very complex queuing system. It looks a bit like Slurm, I think, in some ways, and we are still getting to grips with that. Because we're hosting data other than the LSST data release in our Qserv, we're hosting things like the near-IR fusion data and cross-match data and potentially other data sets too. Our queuing system is likely to be more complicated than the Rubin one, and if we don't set it up right, there is a risk that users get blocked while other queries complete or queries run inefficiently. So we're getting to grips with that just now. A look at some of the user-generated products we are having here in the UK in a bit more detail. So the first one I mentioned was a plan to fuse Rubin data with near-IR fusion, near-IR data from the Vista survey. This is being done by a team in Southampton and Cambridge. Effectively, what they do is they take the deep coad images from an LSST data release, and then they process Vista data to the same point so that they have further deep coad images for the bands in which Vista observes, and then they run the remaining steps of the DRP process on the extended set of bands, which I think comes out to be the 10 bands or 11. I should know that. It might even tell me here. It's going to be 11 bands. And what you get is a new set of object catalogs, source catalogs, force photometry, etc., but now based on the 11 bands of optical and near infrared rather than the 6 bands that LSST produces. We aren't planning to produce all the catalogs. They're not all particularly beneficial over what LSST provides, but we are expecting to produce a reasonable amount of data here to the extent that this processing will all happen on HPC resources. Currently, these are at Cambridge. And we'll be running the pipeline in a very similar way to the Dark Energy Science Collaboration, who are using NERSC resources primarily to do various reprocessing and post-processing of LSST data releases. The second example is cross-match at LSST depth. As I said, there is a concern that because of the sensitivity of LSST, you end up with a lot of crowded fields, and it's much more difficult to perform cross-matching crowded fields. You have to take into account the motion of objects, the proper motion of objects, and the risk that, in fact, you misidentify a cross-match from a much shallower survey, as many of the contemporary surveys are, against LSST. So there's a team based in Exeter who have developed a new algorithm for cross-match called McAuth, and what that does is it cross-matches actually 2 or multiple surveys. It can do more than 2 surveys. And rather than giving you a link between 2 objects in the 2 catalogs, it tells you a probability link between multiple objects and multiple objects in the 2 catalogs. So you can look at various properties and decide which you think is the right cross-match for you, or various other things around that. We are planning to cross-match LSST data releases against a number of other surveys. I don't have that list just now. This is a discussion with the recipient group, which I think is the Galaxy Science Collaboration, and over the next 6 months we'll agree which surveys we'd cross-match against, and then it's possible that other groups can take our software, which is open source, and create their own cross-matches too. Lasair is our LSST community broker, as I've said. The platform aims to provide an SQL-like environment that is familiar to astronomers and to allow them to use that to do real-time querying of the alert stream rather than of static catalogs. There's various functionalities that already exist and are being developed to allow users to filter the data, to create their own feature sets, to look at geometry, and to do various cross-match activities. Sherlock is our classifier. it looks at the alert and it identifies corresponding entries in up to 40 other catalogs, and then uses that to try and classify what kind of object it is that's been alerted on. And users can create watch lists of their favorite objects and get text messages, Slack messages, emails when something happens and their favorite object or objects is the subject of an alert. Lars has been running for quite a long time, actually. It's been serving ZTF data for, I would guess, around about 3 or 4 years in a precursor service, which is very much the basis of the functionality that will go into Lars at LSST. It is currently the most active bit of the UK IDAC. We have, as of this morning, 512 users. I was tempted to make it 511 because 512 seems an awfully round number, but 512 users this morning, and at the last check, there are around about 81 publications that have acknowledged or cited LARSA as the platform on which they have done their research. We have a number of downstream recipients who will take the alert stream that we relay onto them, which will be sort of filtered down to particular targets. One interesting one is the ePesto Plus service, which is looking to select various targets for spectroscopic follow-up with the Foremost spectroscopic telescope. So the aim is that Foremost will try to track wherever possible LSST is observing, so that if something interested is spotted in LSST, there's a chance you can point a Foremost fiber at it and get a spectroscopic analysis of that. There are various other downstream services that are planning to use LARSA as their source for information. All of this takes significant infrastructure, and this is the thing that tends to keep me awake most nights. We have and had for some time had what we call an infrastructure sizing model. It's based very much on information that the Rubin Observatory have modeled themselves. They also have to buy a lot of infrastructure, far more than we do. And we have a model now that extends for the full life of the survey and factors in things like expectations in technology changes, expectations in cost, energy cost changes, and so on. I'm not sure we quite caught the big energy jump several years ago, but we're still just about within our envelope. This was the basis of securing that extended in principle funding from SDFC through to 2036. Our model has 4 categories. We look at data release processing. We look at the IDAC in terms of data hosting, of compute power in the science platform, in terms of support for dev products, in terms of user compute and user storage. And then we also have lines for LARSA, which is actually a relatively modest offering despite its power and its popularity, and for the dev activities. As I mentioned earlier, at least the near-IR fusion work requires significant compute time, and we have to budget for that. The key document to read if you're interested is DMTN 135, which is a summary of the project's model. That is backed by a project spreadsheet, which I think is project internal, but potentially if people need to know that information, they could get access through that with the permission of the DM team. But the key information is all in DMTN 135. And we have done various experiments to validate that up until now. If I look at some very summary views of that for the DAC and LARSA, here you can see the CPU power measured in millions of core hours and the storage, a mix of normal storage and object storage that we're expecting to be able to or require to make available at particular points in the life of the telescope. So as you can see by the end, we're expecting to be running around about 230 petabytes of storage. The vast majority of the budget, actually, I think around about 80% is on storage. The compute costs are relatively modest. This is very much a storage expensive offering, and I suspect the project has a similar situation to be in. LARSA, as I said, is a relatively modest offering, relatively cheap, but in that way, very good value. In terms of CPU, it's very modest. It can be served by a small number of servers. And in terms of storage, it's also pretty modest compared to LSST. One of the interesting things, I think, related to the fact that we have this sort of near real-time processing is they rely very much on in-memory processing and on fast storage, currently sort of NVMe type storage. And so actually their server costs tend to be a bit higher than the typical server cost we use for LSST. They need to keep data in memory so they can process it quickly. They need to be able to classify against these catalogs quickly, and NVMe storage provides them with that capability in the way that more cost-effective spinning disks do not. Look at our status. So as I said earlier, we're on what's called IDAC 4 in our roadmap. And what I haven't said is Lasair is on version 6. We will move to IDAC 5 in July, and Lasair will move to version 7 in April. If you're a Lasair user, you're probably on the mailing list that tells you what changes there. The key the key thing for Lasair is that they are debating how to move from ZTF to LSST. There has not been a long-term plan to continue to serve ZTF indefinitely. It is very much a means to an ends, and it's likely that the LSST data will become the predominant service once that data is available, and that's likely to be, I guess, from late this year. Our IDAC, as I said, one of the biggest weaknesses we have at the moment is a lack of users. We have around about 20 or 30 users, but not all of those are using the system in anger. We do have some interesting use cases. So there is a group in primarily Exeter that are science validating the Gaia Catways crossmatch data, which came out of Macau. In fact, they found a number of problems and have led to various iterations of that. We are going to produce a new version of the Gaia Catways catalog in the coming weeks and publish that to our IDAC, and that's available to all users. So if anybody's interested in that, we can potentially get you an account provided you're an LSST data rights holder. DP02 is probably our biggest catalog and image set, but actually it's a very limited use. It's simulated data, and you have a much better offering from the project. What we have found it useful for is internal benchmarking. We have used it heavily to benchmark Qserv. We have a number of benchmark queries that we run, and also ingesting data into Qserv, which is quite a challenging operation. We have tested heavily with DP02. DP03 catalogs we've had for a while. They will support the solar system team who are in the Adler project. I haven't talked much about that here. As I said, if you are interested in that, I can find you more information and put you in touch with the people involved in the Adler team. And we have a very small amount of ZTF data from data release 20, which has been ingested specifically to allow Lasair users to experiment with accessing data release products in the way they may do when they're running on the Lasair Community Broker with LSST. Recently, we actually started work with the community science, with a citizen science team. I think it's the Rubin citizen science team. So they have set up a number of notebooks on our IDAC, which will allow them to prepare products which are then deposited in a Zooniverse store where they're accessed to the public, and public can do their citizen science on those. So that's been set up recently and is another good example of where we are actually seeing genuine use of our IDAC. And not too many complaints, so that seems a positive start. So, in terms of summary, oh, sorry, I have missed a slide. I am one slide early here. So, some of the key things we're doing now to prepare for early science, service hardening is a key. As I said, we've been running our RSP and our Qserv instance and our various other services for some time, but we don't have a lot of users and we don't have a lot of confidence in their resilience. So, we're doing a lot to try and break them. And to understand how to throttle and how to deal with failure and how to respond quickly to provide a good quality of service. We're delving into how to do demand management and things like service level setting in RSP, which is non-trivial, in fact. I mean, one of the big concerns we have is the days immediately following the release of one of the data releases, but also possibly one of the data previews. It's likely that we're going to get an intense hit of users who are all keen to do something there and then. We need to be able to throttle that use so that it doesn't break the service, even if it means people have to wait in a queue or get a less satisfactory experience in the first instance. The key is not to break the service. As I said, data management, distribution of data is expected to happen via Rusio, and we are ready to participate in those experiments. The IDAC coordination group have already set up some early pilots with a number of groups I think CADC is one of those groups, and Stephen on the call here can probably talk a little bit about that. Once that is completed, we are hoping we can integrate our Rusio storage endpoint in that and be part of the next phase. As I said, we're looking to try and to save money, but also to support more batch processing oriented workflows by dividing our data release into hot data, which is the data we're expecting to be hit frequently via the science platform, and cool data or cold data, which is possibly data that's going to be more of interest to groups who are organized and want to do large scale reprocessing. So things like the single visit images, which we see most value in being able to take a certain chunk of the survey, deposit it in an HPC resource, and then do a rather significant batch processing type analysis on that with pre-secured time. And we're experimenting how to do that. It has potential analogs to how the Rubin hybrid model for their data access center is working too. We've talked about authentication, authorization. Both of those things currently we're on the old model and we need to move to the new model. And there are some challenges on the path to that. But actually, I think we have a plan that will get us to something that's workable in time for DP1, even if it's not complete. And metering access. So we've committed to providing a certain amount of resource. We need to be able to demonstrate that we're providing that. And one of the ways to do that is to account for use. We also need to make sure that we can understand how users are accessing the data and highlight those that are making significant consumption of compute time. That may or may not be legitimate, but we need to at least know. And the accounting aspect of the science platform is still a bit of an unknown to us. Integration with Lasair, we actually don't have any strong use cases to integrate our community broker and our science platform at the moment, which I was initially surprised at, but then I'm not an astronomer, so maybe I'm missing the point. But it's very easy to provide shared services. So Nublado, which is the notebook service, is now accessible from either Lasair or from the science platform, and users of both services use the same Nublado services. Things like the TAP interface and the what's the image interface? SOA interface are also directly available from either the Lasair side or from the RSP side, all sharing the same data. And as I said, with things like Lasair being public data and with potential access to other proprietary data, the authentication authorization challenge is potentially more complicated than if you're just serving Rubin data releases to data rights holders. And science support via the community forum. We don't have a lot of science support at the moment. There isn't a lot of science happening on the UK IDAC at the moment. But as that grows, we have a resource of computational astronomers here in the UK who are ready to start engaging with the community and hope them get the best out of that alongside Melissa's team and the like. Right, then I go to the summary. I've got those slides the wrong way around. So hopefully I've showed you that UK astronomers are working together, and we have done that for some time now. And the idea is that this will allow us to maximize our opportunity from the Rubin Observatory. But just because this is good for the UK doesn't mean it's not good for the international community. And through our in-kind contribution, everything that we're doing is being made available to all Rubin data rights holders. And we hope it's equally useful and beneficial to them too. We have quite ambitious plans. Our independent data access center is, I think, the only full independent data access center. It's a little bit scary. It's a little bit trepidous. We don't have a lot of users yet. It's all going to get very real in around about 6 months' time. But we are also looking to offer added value on top of the Rubin DAC through the user-generated products we have here in the UK. And a big thing that keeps me awake is the infrastructure costs. This is a lot of infrastructure, and we have a sizing model, we have a budget, but who knows what happens in 5 years? Technology changes very quickly, the world around us changes very quickly, and what we've planned for now may or may not make sense in 2 or 3 years' time. Rubin operations is on the horizon. I think this is very exciting. Occasionally, I think this is very scary, but most of the time, I think it's very exciting. So I'm pretty sure that's the end of my slides. Thank you very much, and I hope that was useful.
Awesome, great. Thank you so much, George. Really appreciate that. We have a few minutes for questions. Let's see. I saw Tim Lister got his question in there first. What is the scope of Rusio? Is it a pan-Rubin, so it can say this data should be on the summit, this data is at the USDF in Edinburgh, or more local and designed to deal with the data locations for IDAC? UK IDAC?
So I don't believe there are any plans to use Rusio to get data from the summit. That goes over a dedicated long haul network into a restricted area at Slack, where it's embargoed. And I think that is being done using in-house technologies. Once it gets into Slack, the data is then in the Rusio space. And the initial Rusio deployment has endpoints at the three data facilities in Slack, in the UK, and in France. And it's used to distribute raw data out to the three facilities for processing and then to return processed data back to the USDF, which will create an entire archive of all the data sets. It's then likely that other IDACs will be registered in the same Rusio. I don't know what it's called, but I'm going to say the Rusio environment, the same Rusio world. And using the right policies, once those processed data sets have been science validated, you can enact policies that mean that the data is automatically transferred out to the data access centers. I think the progress with the current pilot that's happening with CADC in Poland will determine exactly how that works. But one of the ideas is that potentially you'll have a tiering where data will be served from either Slack or from IN2P3 to a small number of data access centers, which will then relay it onto other centers. This should all be automated because it's all done by Rusio through policies and by FDS. But that's the plan. There's no connection to the summit for Rusio, but once it arrives at Slack and it leaves embargo, then I think it's in the Rusio world for the rest of its life.
Great. Yeah, I think I yes, Tim is asking for his reasons. So I had actually a related question to that a little bit. You mentioned the data releases, of course, those are going to be large and nice and chunked and ready to go. You also mentioned data preview one. I've been curious, is the plan to transfer data as things happen, or wait until DP1 and wait for the DR knowing that they're going to be reprocessing and stuff like that along the way?
So I think DP1 is a special case because it is being processed in advance of first look, which is a significant date on the Rubin calendar. But I think once we're past first look and we're in operations, things will change. The hope is that we can receive data as soon as possible. Depending on when data is finalized in the pipeline. And there are still some open questions about the exact workflow that will be used by the pipeline. But as soon as, for example, process visit images are available in the pipeline, which potentially could be around about a quarter of the way through the timescale, I think it's sensible to ship those to the DACs and to embargo them there. There is a risk that science validation will identify that something went wrong and those images are substandard or completely useless, in which case we may have to abandon and retransfer, but I think it's worth the risk. I think if we have to leave everything until the end of processing, it will never be published in a timely fashion. So the more data we can get, the better. What I didn't touch on particularly there, although I did hint at, currently getting catalogs into Qserv is very expensive. DP02 we have got down to around about 3 days, and that's only, I think it's maybe 10 billion. No, maybe I don't remember. It's certainly at least one or possibly two orders of magnitude less than a data release. So I don't think we can spend 300 days doing that. Admittedly, this is on a 10-node Qserv with spinning disks, so there are elements of slowdown there, but there's not two orders of magnitude elements of slowdown there. So the ingest of Qserv is a problem. The sooner we can get the catalogs and process them, the better. And even IDACs that are using Postgres, which I think is probably the favored alternative to Qserv, it's going to take time to get that data ingested and indexed into the catalogs, into the database engine before they can be served to the community.
Great. Okay, well, we only talk about that as a quick question, and as the host, I'm going to steal it.
Go on.
I noticed you mentioned on your chart CPU hours and time usage, etc. I'm a citizen science person myself and use GPUs for various inference things. Are there any GPUs at all in the IDAC? Is there a plan for doing anything with GPUs? I know this is also the popular question of the day.
Yeah, so not currently, but I'm assuming there will be at some point. The reason not currently is because up until recently, I don't think DM and Rubin have talked much about GPUs, certainly not in their DAC offering. Where I think it's immediately interesting is when people come to do large scale analysis of images, potentially using things like machine learning based algorithms and so on. So here in the UK, we have a new AI facility. It's called Isambard. It's hosted at Bristol. It's a pretty large infrastructure, and we are bidding for resource there with the plan that we would be able to deposit image sets or whatever sort of training data you would like in there, and then people could do the things like their machine learning models on that. It's very much in line with, well, I maybe didn't explain it carefully enough, but by depositing a lot of the batch interesting data at RAL, it means it's very accessible from the various HPC centers around the UK. It's on a 400 gigabit network. It's directly connected to key HPC centers via Janet. And so it should be reasonably easy to stage significant chunks of data in from RAL into working storage at an HPC center and then process it, which is the only way I think you can really do this kind of batch processing. We've been
Great.
doing experiments really with things like, I think we can do about 300 terabytes in a couple of days, which is not a bad rate. And I think given that these things grow over time, by the time we get to LSST scale, that means that an experiment with a bit of organization could stage the data they need in maybe a week or so, which is a
Great.
viable
Thank
time
you.
frame, I think. Yeah.
Yeah,
Sorry, that
that's
wasn't a
awesome.
GPU question. That was not a GPU answer, but I did start by talking about
No, but
GPU.
we could get it to somewhere where there are
Yeah,
GPUs. That
yeah.
was
Sorry.
my
Yeah,
immediate
sorry.
takeaway. No, that's quite right. So we're almost at time here, so just wanting to wrap up. If you wouldn't mind stopping screen sharing, that would be great.
Yeah, sure. If I can work
Thank
out
you
how to
so
do that.
much again, George, for this awesome talk. Very fascinating. Thanks everyone for attending the Tech Talk today. Our next Tech Talk will be on April 10th, 2025, when we'll be joined by Matt Holman of the Harvard-Smithsonian Center for Astrophysics. Matt's going to talk to us about their the Link Framework Incubator Project Layup, which is a solar system object orbit fitting tool set. In the interim, please join the LSST Discovery Alliance hashtag Link Tech Talks Slack channel and link at lists.lsst.org mailing list for more information and future announcements. There's more information, including links to Rubin Community Forum and calendar at the Discovery Alliance website. Link Paper is also holding, this is new, office hours every Thursday at 10 a.m. Pacific, except when it conflicts with this talk. And we will show a slide in a moment with link to that. If you have an idea for a tech talk, we would love to hear from you. Please feel free to reach out to myself or me via the LSST Discovery Alliance Slack or via email. Listed on the Tech Talk webpage. And with speakers already granted permission, we're going to be posting today's Tech Talk on our YouTube channel, which is also linked from that website. We thank you very much for that. I'm going to go ahead and give this a shot and see if this will work. And it says that. We're going to just leave that alone. So for now, I want to thank everybody again for joining us, and please have a great rest of your day. Thank you.
Take care, everybody. Thank you.